Welcome back to Educator.com, Intermediate C++. Today we're going to be doing some more work on object-oriented programming, some more things that you need to learn about. Okay, now with all sorts of various ways of overloading, we didn't have time to cover overloading of the constructors much last time, so today we're going to cover a little bit more of that, how we can overload to allow different ways of initializing the new object that you're constructing. So we can have an initialization list is a unique way for a constructor to initialize each of the members in the particular object. And we're going to talk about destruction a little bit. So once you construct something, you always have to destruct it, and which means I need to go get some memory for this object. So, okay, I don't need it anymore. Just give it back. And we'll talk about the class members and parameters. A little bit of discussion of giving them meaningful names. Like if it's the age of the widget, don't call it A, call it age. The three letters of type. It's not a big deal. Functions and classes can also be a friend, because we're breaking the object-oriented rules a little bit when we have friends, but sometimes there are occasions where you need to have that in your design. So we'll have friend functions and classes that allow you to write a specific class or specific function that is outside of your class but still has access to the private members. Now you can design your classes to have subclasses. You should not really, in general, just, here is a great class we can derive from that. No, you should take a great class that has been designed to be derived. The methods are designed to be called by somebody that derives from it. You've got protected members, etc., etc. Virtual functions that will be overridden properly. And we're going to talk about separating your classes into compilation units and an interface header so that you can have a object, the code for that object in a compilation unit by itself. You say, okay, here's my compilation unit. You can now compile this with all the other compilation units that are part of your application. And we'll talk a little bit about when not to use object-oriented techniques. I mean, you'll see a lot of stuff out there about how wonderful object-oriented stuff is, and all the different things. Many programs out there that didn't used to be object-oriented or now have got object-oriented ways of handling their particular code, because object-oriented is a good way to do things, but there are occasions when it's overkill. So we'll talk about when it's not appropriate to use object-oriented techniques. Okay, we're going to overload some constructors. So every time you use the same name for a particular function, but just in this case a constructor, but you have different parameters, you're overloading it, which is a kind of polymorphism. So it's useful to provide other constructors. Now, also notice, if you provide any constructor at all, the compiler will not write a default constructor for you. You may need to also have a default constructor. So here we have a default constructor for horse. So the horse class has got a name, it's got a speed, it's got the time it was created. And we'll include the time header so that we can get the time t type. And we'll also get the time function. So here we have a default constructor. We're just constructing a horse, just some horse, and rather than having an unnamed horse, we'll just give him an empty string as his name. And since we just created him, just constructed him, his speed is 0, and we want to know when this horse was constructed. So we'll say the time created is equal to the current time. Now, we may want to give a name and a speed other than the default. So we'll have an overloaded constructor. We promise not to change this parameter. We're going to give it the name and a speed. So I've got n is going to be the name, s is going to be the speed. So we're going to construct this horse and set the name equal to n, set the speed equal to s, and set the time that is constructed. Now, we're not going to allow the caller to change or set that. Could be this is something that is private. The time it was created is private. Now, we might want to return to the caller, let them know when it was created, but we don't want the caller to be able to change it. And since it's a private member, we don't have to give them access to it, so we won't. But in each constructor, this definition is when this object was created. Every constructor that we have to write will set the time created equal to the current time.